Welcome back to today's episode of Decompiling Dinosaur Planet. Today we're going to continue decompiling Kyte, which is DLL 212. Last time we decompiled the last 5 functions of this DLL, well, last 6 functions, and today we're going to just continue going bottom up as we did last time. So in case you missed how the basic things, how the basic workflow of this works, I recommend checking out part 1 of this, or the first part of this, because I go over how to set up the DLL, how to look into how to get into files. Today I will not go into as much of a detail in regards to setup, but I continue going as detailed as I did for decompiling itself. Alright, so let's just start off by copying the assembly and then creating a new context. So Python NumPy context. And as you can see here in the history, I committed the changes that I made just a second ago, because committing changes regularly is good. Right, I forgot that I need to actually pass in the file. Let's see. There we go. Now I can copy all of this. I can paste it here, and I can create the scratch. Alright, well, it looks like we got kind of lucky on this one. Everything's compiling already, and we are already down to a score of 10, which will be 0 or matching as soon as I change this. Right, but as we all know, we usually want to be cleaning up stuff after we are done with it, which means that we'll have to look at what we can actually clean up. In this case, what is this function actually doing? It's determining a curve setup. It's starting with a null curve setup, and then it's calling this DLL25, which I think is the curves DLL, and it's checking something about it. Alright, this is reading this. This might also be not directly assigning this, but instead just doing something like... it's doing something like this. So this do while loop is essentially just it's essentially just a for loop, but MPC tends to do a do while loop or sometimes an if do while loop. We're probably gonna find one of these later on in the episode, but yeah, so this is just iterating over this data until it reaches this point, and this basically is just iterating 4 times, because the difference between this 1AC and 1BC is 0x10 in hex. So basically this is just iterating over this element 4 times, and we can kind of confirm that the length of this is 4 if we actually look up this data, and we can see that this array has 4 elements. Alright, that means that I can now do for I equals 0, I smaller than 4, I is plus, and then I can do this. And then instead of dereferencing var as 1, I can do this. And then hopefully, after removing this little bit of code, we should be back to matching. Alright, that's awesome. Good stuff. Now, I can remove this variable because it's not used anymore. I don't think I can really remove anything else. No, I don't think so. That means the only thing left for me to clean up is calling this self, and then I can make this an SF2. Alright, then let me copy this, go back into the code, and then enter this here, and then let me change this to be an SF2, and I just realized that I forgot to rename this and this, but that's fine. Now I can also What did I want to do? Yeah, go right. So in here, you can see that these values all have these leading zeros, and you technically don't need them. So let me just prove this by running the build, and hopefully this should match. Take a hot second to compile, but that's fine. It's trying as hard as it can. And we got an okay. Awesome. Alright, then again we don't need these 6 leading zeros, because right now do the build again. You can see it still compiles. It's just pairing. And we probably don't need this variable as well, because this was just marking the end of this. So we can probably search for this variable and then search for it not inside the assembly, but inside it in this sys.txt. We move it here, and we move it here, and then compile again, and we are still matching. Awesome. And similarly to what I did here, I will just move all of this onto one line, because I think it's just a little bit prettier. Alright, awesome, good stuff. That's one more function down. Let's just move up to the next one. So, copy the path, open the file, copy all of this, go into here, create a new scratch, paste all of it in here, and then just create the scratch. Awesome. It's taken a little while, but that's fine. Alright, there we go. Now, we have encountered something where it didn't compile directly, and there's probably multiple reasons for this. The first reason being that arg0 is a void pointer again, which it looks like it's accessing it in a way like an object would be. So just by looking at this, like unc.ac is pretty high, and so my guess would be, since it's in related calls to object create, that this is just an object. Let me just do this. This is not going to really improve things, but let's keep going. Then let's see. I don't quite know why it thinks this is a double pointer, because it's causing problems, but that's alright. We're gonna manage. Let's see. Let me just. Yeah, let me just do the 0th index of all of these, and that doesn't work. Awesome. Okay, so let me see. So unc14 is, if I remember correctly, srt runs l.x, no, sorry, z, because unc is srt runs l.x, and then unc10 srt.transl.y. And I know this because if I look up the object struct definition, like, one second, here we go, like this, we can see at the very beginning of the object there is an SRT, and if I look up the SRT struct, like here, we can see that at position C it has x3f, so an array of 3 floats, and the first one is x, second one is y, third one is z. So at position C there is x, and then +4, because the float is 4 bytes big, we would be at 0x10, which is going to be y, and then plus another 4 bytes, so 0x10 plus 4 is 0x14, so z. Right, okay, but we are still missing a few things, which, for example, is unc30. So let's just go back to the object, and then hopefully There we go. See that something is at position 30, which is the parent. And now we can see that I actually was incorrect, because Ank30, this isn't an object. So we know that my assumption about Arg1 is entirely incorrect. That's fine. Mistakes can happen. It looks like it's going to be something different then. That's alright. Let's just let's then go ahead and just create a custom thread for now, because I have no idea what this could be. Like this, and then we know that Ank0 is going to be a void pointer, most likely anyway. Well, although I'm a bit confused here. This should be correct, but it isn't. That's kind of weird. Let's see. Okay, let's actually not see. Let's remove this, and then let's just write this into here. And then, while this may not be correct, we are going to accept this for a second. Alright, then what else is incorrect? We have this, and this is loading an object setup. You can see here it already found this object setup, but it doesn't know about Ank1A because this object setup is a bit bigger than the default object setup. And we can find this object setup by, well, first of all, converting this value into from hex into decimal, which you probably can't see right now, but that's fine, which is 1264. So now we can go back into the code, and then we can look for the DLL ID something, I don't know, maybe, probably Python, whoops, DLL ID, and then paste it here, and we can see it's this, but this doesn't really help us. This would be, well, I'd assume it's an object that's all the way down here, but we don't have this decompiled yet, so we are going to have to get a bit creative. So let's just do type-diff struct. Orbital setup. Let's just do 1, 2, 6, 4, and then this has the basic way of defining object setups or extending them is like this. You basically have the base object setup in here, and then you just do all the fields that you need on top of it. So let me just do the same here. And then we saw that we needed Ank1A, which I suppose we could be doing something by U16, pad 118, and then we can do Ank1A, and then we can replace this variable with this, and then we need to just all of these rights here need to be replaced with a base in front of it, and then this needs to be removed, and now this is compiling again. That's awesome. Alright, let me just change this to an S16. Probably doesn't really matter here, but just for completeness sake. Right, then we need to figure out Ank30 and this one. Actually, let me look up the signature of object create. Okay, it is in fact the parent. So this was called parent before. Let me just use parent. And then let me just look for, well, unc.ac is not going to be all that helpful. Let me just do search for the object struct again, and then search whatever is at unc1ac. It's the map ID. All right, map ID. Awesome. Then next up, we have another object alloc setup. And what we can do again, we can try to use the DLL ID script and see that this is actually DLL 212, which surprisingly, or not surprisingly, is Kyte. Alright, so that means that we can now kind of infer the object setup for Kyte herself. So let's just do that, I guess. Struct, and then Kyte obj setup. I think that is the naming scheme. Let me see. OBJ setup. Yeah, it's the DLL, and then it's just, oh, it's no OBJ setup. Okay, so it's just Kyte setup in this case. And then again, do the base variable. And after that, we need 18, 19, A, C. Alright, let's start off. So we need U8, UNC18, U8, UNC19. Let me just do this, and then already replace the type. So I can already, for example, replace these and this one, and then we can see that 18 and 19 are already fixed. Now we have UNC1AC, UNC1A, UNC1C, UNC1E, and my guess here would be that they are all 2 bytes big, so either a U8 or a they are either a U16 or an S16. I will just go ahead and do a U16, and if this field is ever loaded, we'd actually know the type, because the loads are specific to the data type. So if it's unsigned, it will do LHU, so load half unsigned. If it's an S16, it will just do LH, which is just load half. But if we started with an unknown or with an unsigned, it doesn't change storing the value in itself. So let me just do this. Alright, then we need 20, and then next up we need 22. So 20 might also be another case of the U16. And this is all just guessing at this point. Like, I don't fully know what these types are, and I will probably know once this compiles and I can look at the assembly. But let's just get this to compile first, and then worry about correct data types afterwards. So we have UNC22, we have UNC23, we have UNC24, we have UNC25, we have 26, 27, 28. Alright, and UNC26, UNC27, UNC28. Now, we know from this function call that the size of the setup is 2C, and we are currently only taking up space all the way to 29. So what we can do is, call this pad 29, and then do 2C. This should take up all the space to 2C. And while technically this probably isn't necessary, because C's padding will align this to 4 bytes, and we'll just pad this automatically. It's just cleaner to the user to tell them, hey, the size of this struct is this. Alright, and then what we can do, because we have these comments in other places, we can just select this white space, navigate all the way over here, select these two, and then just add the address as a comment here. These make more sense when these aren't called like unc or pad, but instead they are, for example, called xcoord. Xcoord. So if a property is called this, you wouldn't directly know that this is at offset 18, and sometimes you actually need to know the offset when M2C isn't fully capable of determining the correct type. But that's alright. Okay, now that we have adjusted this size, what we can do is we can actually replace this one with just size of, and then this one probably needs to be replaced with a constant that I don't know where it is currently, but we can probably figure this out. And similarly, this object alloc setup needs to be replaced as well. So let's just do this, and then whoops, and then we need this to be this, and then similarly to what we previously did, I will do pad C all the way to 24. Alright, we are getting closer to being compiling, or to compile. This one is the same code as above, so I will just go ahead and copy paste this. And then this one also needed this. And that didn't work. I don't know why it didn't. Or maybe it did. Yeah, it's just not properly shown. It is. Let me just save. It is. Oh, it is actually complaining about this. Oh, right. It is supposedly. Ah, right. It's trying to save object create into this. So let's just remove this altogether and then see we are already compiling. Awesome. Alright, I don't know what that's about, but we are compiling and that's a good start. Now, we want to be looking at what's actually wrong here. And so we go from top to bottom and slowly but surely make sure that whatever we are doing here is, or what is, or just check what is actually wrong here. Alright, so we can see here that this is actually trying to load a word, but in our case it is, well, it's loading a word which is partially correct, but it's loading it from the wrong offset because we're doing this 0. We are dereferencing this essentially, and then it's loading a float out of the 14th offset, which the offset is correct, but it should be loading a float, but it should be loading a just a word. So something has gone wrong here. And then similarly, we can also see that it's trying to store a word here, but instead it is, what is it doing? It is, yeah, it's storing the float one in here as well. So this is definitely not quite an object in itself, but instead something else. So what we can do to maybe see what this might be about is we can look at what DLL load deferred returns, which is a void pointer. Well, how is it used in code? Let's see. We have this, and then, okay, so it looks like, well, this is just loading as the name kind of implies a DLL. So it would appear as though this saving is just storing a DLL into the first value. So this might just be, well, we could just go ahead and turn this into an S32 and then go from there and then see where things might break. So let's just do that. Alright, so let's first off change this. I will just select out of these occurrences and I will change this to be 6. Actually, yeah, let me just do this. Make this only a single pointer, and then we can already see that this has cleaned up nicely, and some of this stuff down below has also been fixed, but we don't care about that just yet. Alright, and I just noticed that I was incorrectly counting, so you can see it is reading from 18, but it wants to be loading from 14, so that just means that I incorrectly counted, and this is 5, because 5 times 4 is 20, and 20 in hexadecimal is 14, and 6 times 4 would be 24, which is 18. Alright, let's save. Then next up, we previously uncommented this one because we didn't actually know how to properly set this, and now we can kinda do so. we can just, well, we need to set offset 30, so let's just try 10 and see how close we are. We are off by 8, so let's just increment by 2, and we are there. Awesome. Alright, then we have this, and we probably want to be looking up what this DLL is, but we can do that later. For now, these magic values are fine. Alright, then we are doing some stuff in a loop. And that stuff in the loop is something, let's see. My first assumption would be that this Ang1A setting is incorrect, so let me just double click this. Okay, no, this looks fine. Now, next up, what I can see is that there's this SRA call by 10, and then before that there's also an SLL call. This is because this is essentially just casting a value to an S16, and we can see that it happens on S0. So what we can try in the first place is to just track down if this is correct. So we can see S0 is incremented by 0x8, which is 10. I'm just going to convert that right now. And we can see var S0 is defined as S16. So let's just change this to an S32. And we can see these SRA and SRA have now been removed, which is a good start. Alright, awesome. Now, what else do we actually need to do here to get magic? Now, 0x1e is... I don't actually know. Is it like 30? It would appear so, because nothing has changed. Now, if I change this to 29, for example, you can see this actually changes as 5. If I just go back to 30, it's back to 1e. So that's telling us that this is probably correct, which is good. All right, then what else might be wrong here? V0, let's click on this. It looks like the order in which it saves is a bit off. So let me start off by moving this up so the XYZ saves are all in line, and that looks like it's already improving stuff. Now let me also move these above, which is not better. Okay, let's move these down again. Then let's see, we have this increment by 10 seems to happen a bit further down, so let's just move this further down, and we can see that it's not fully correct. That's fine. Now, something that we can do here is, because we know that var S1 is just arg1, what we can do here is kind of do like treat S1 as an incremental variable, so like I, but instead of just using S1, we're just going to create I. And then I will go ahead and do for I equals 0, and I smaller than 3, I get back to y in a second, and then do this. And then we move all of this, we move, not this yet, but this var S1 we know was just this one, and we can do this. And you can see things are being cleared up a bit, and now we can remove var S1 entirely, which is awesome. Now, let's look at this. So this seems to work. Let me just save this for a second and then move this plus 10 up a bit. Yeah, it's a bit incorrect still, but it's already a lot closer than previously was. Now, why did I actually go ahead and do iterate until 3? I didn't just randomly pick this number. I know this because this previously, let me just decompile the stuff again. We previously checked against var S0, and we incremented by 10, and we incremented until we reached 30. So technically, this was just iterating 3 times, because it's 0, then 10, then 20, and then it stopped, right? So, given that we know this, what we can do here, we can also get rid of var S0, and that's because this technically is incremented in the same way as I is. So at the end of the loop, technically S0 should be incremented by 10. But what we can do instead is, instead of keeping track of a separate variable, we can just take I and multiply it by 10. And you can see this actually helped us a ton, right? You can see all of this is white now, for the most part anyway. And we can just remove var as 0 altogether. And this is like one of the things that aren't that obvious if you don't know about them, because you have two separate arrays or pointers that are accessed, or rather they are indexed by the same variable, but in the decompilation output, like here, they are kept track of in different variables. And sometimes you can get away with just reusing the same variable, and sometimes you can't. There is no like rule of thumb. It's just like you have to try things and then see how they turn out. So in our case, we got lucky by just using I times 10. Sometimes this doesn't work, and you need like that separate variable, but that's more on a case-by-case basis, and there's no like, you should be doing this if this or that. There's no such thing, at least not that I'm aware of. All right. Next up, what we can do is, or what we need to do actually, is we need to increment this by 1 to fix the offset here. And this kind of also gives us a hint as to what the data structure of this might look like. Because now currently we are at a point where we don't know what this is, and before this +1, this assignment would technically have been overwritten, and we don't want that, right? This wouldn't make sense. Like, why would you call a function and set this value just to override it in a loop? But now we know that this actually doesn't do that, but instead it offsets this by 1. So technically, if this was a struct, this would basically write to unc4. I will change this or clean this up later, but let's move on to matching. And what I will do before though is, since this F32 gas is probably not necessary, it doesn't look like it, I'm just going to remove it, and the same for the U for the unsigned. Awesome. All right, let's move on. We have this object create setup, and then again we have this lonely Z coordinate right at the very bottom. Let me just start off by moving this all the way to the top. And we see, I think, a slight improvement, so let's just go with it. All right. Then next up, we can see that we have A3 and V1, and they are written into the same, or into the correct offsets, but they are loading the incorrect value, which is -1. And this is where, well, I made a mistake, and that's fine. I declared these as U16 because I said, well, when loading these, it's pretty obvious that something's wrong. But sometimes when you write like the maximum value, so for a U16, this would be 0x4fs, or for U8, this would be 0xff, it's being treated differently. And also, a -1 wouldn't make sense, or a negative value wouldn't make sense for an unsigned value. So let's just go ahead and change these to signed values, and you can see this A3 is now a -1, as it should be, and is being stored in the correct offsets. So that's safe for now. And then move further down. See, so this is correct, this is correct. And if you're wondering why I sense that this is correct, I am on this line, and on the right side, it's also highlighting this line, and it's white. So for now, I'm just going to assume that this is correct. Moving down, moving down, moving down, all the way to here. And something seems to be wrong here. So this is trying to write T7 into the 19th value, but it's reusing the one that's stored in this value. And my first guess would be that these are technically two different values, and in order to trick or convince either into doing that, we need to change either of these to be, well, one of them has to be a signed byte, and the other one, or character, and the other one has to be an unsigned character. So let me just make this an S8, So Ang28. I don't think it really matters here. We can make either of them an S8. So if I go to Ang19, we can also make this an S8. And you can see it fixes them in both cases. So what I will actually do is I will go ahead and make Ang28 the S8. But add a comment if this needs to be a U8. Then Ang19, yeah, and Ang19 has to be a S8. Just so that in case someone else edits this to be a U8 because they have to load this as an unsigned byte, they can see this comment hopefully and realize that they need to update this. It might be me, it might be somebody else completely, it might be you, who knows. So just that if something breaks, the author might already have a clue as to where it could be. And then finally, we can see here there's another incorrect load of a value, which is T0. It's loading a negative value, but it wants to load a negative value, but we're currently loading a positive value. And we are writing this to 1C. Which means that again we need to make 1C an S16, and we can see that this is now matching better. Awesome. Alright, then we still have a small problem. Well, we have a couple, but that's fine. We have this T7 and S4, so let me just go ahead and actually swap these around. So make this a U8 and this an S8 again. And actually, that seems to be more correct. So let me just move this comment all the way up here. I doubt that this would ever become necessary, but I'm just going to keep it here in case it might be helpful to somebody else in the future. Again, I don't think so because we just found out that this has to be in this order, but it's also possible that, for example, we need to switch these assignments and then things just work out. It's just sometimes we make assumptions to get things to match, and then later on we find out that, oh, actually we need to change something up because we found something completely new, but that's fine. Alright, and then last thing that we need to fix is this needs to be a 4, and now we are matching, which is pretty freaking good. Alright, so let's see, we have something in this, in 0, we have something in 1, in 4, so this technically Ang0, Ang4, Ang10, Ang14, and I remember having something similar for tricky, so let me go into the code, and if you just start out on this in Decomp, you probably don't have the memory of oh, I remember seeing this and this and that somewhere. So what I tend to do is, well, in this case it's a bit tricky to give you a good example here, but what I could do is search for this 1F4 value and then see if it's assigned somewhere. And I'd be looking at a straight assignment, so equals this, and it looks like this value is also a game bit, which is good to know. So let's just assume that this is actually a game bit. Actually, no, we shouldn't. We can make a comment. Let's just copy this value for a second, and then do maybe this, and then go back. Actually, let me check. This is offset 30. So what we can do is do 30 equals, and then sometimes, okay, no, this isn't the same, so we can't really find the struct here. So let me just see and go into the tricky DLL and then do. What am I looking at? I'm looking at this. No, I'm not. I'm looking at this. Right, okay. As you can see here, it's similar, but not quite the same. It's loading into Ang0. It is loading a DLL deferred result, and it's also loading the same thing, or it's like creating an object here, and then it's also creating an object here. It's just a different struct offset. So this is part of the data, and so we can kind of assume here that this arg1 is just DLL12 data. So let me just DLL12 data, and then let's hope that this actually exists. It does not, because I probably typoed this. I did. All right, then we need to go into data and then change a few things. Well, we already have some data defined here, apparently, so something's a bit incorrect here. In that case, let me just do a new struct for now, and then DLL2 data 2, because I'm very creative with names. And then we know that Anx0 is a void pointer, so let's just do this, and this is the noded DLL. And then we know this is Anc4 because it's technically, well, it's 0 plus 1, so this is just the object pointer, and then it's Anc4, and that's 3 elements here because we are incrementing to 4, we're incrementing to 3. And then we also have this fourth one, which is another object, so let's do this. And then 5 is 50, is 14, so let's just do this. And let's start replacing values. So arg1 this, the fifth entry is arg14, this is arg0, this is arg4i, and this is arg10. And then the only thing left to change is actually this one. And this one is, I think I remember being 30. And I don't need to actually remember because hopefully, okay, I can't. Okay, so I actually have to see it's this call, it's offset 30. So let's just do S32 out 30 just to get this to compile in a hot second. Out 30. And we can see that this is incorrect because I forgot to add padding, and that's totally fine. So that's just a pad 18 all the way to here, and then we're matching again. Awesome. Now, what we now can do is possibly... Oh no, we can't actually remove any of these variables because they're all used. We probably want to investigate why or what this data structure is. Actually, I changed my mind. I want to change this to be this, and then might be, and just add a comment. And then later on I can investigate whether or not my current data definition is correct or whether this definition is correct. Alright, now something else we can do to clean up. We previously had these magic numbers, which all are DLL IDs, and we can actually look up the values for these. So I saw here that there is this. Okay, there's this enum, and I have this DLL header, and apparently I can, or there's just there's these values, and I can use these. So let's see, let me just move this to the right. And some of these values might not exist here yet, so we might need to add them. So, what 10 for A? Is there a 10 for A? There is! Okay, and it's this DLL. So let's just do this. And this works. And you can see my gut feeling of code being similar. We could have also checked for this value, so we could have checked for this. And then we might have found this DLL, and then going back over this DLL, we could have seen this. Alright. Then next, 4F0. Is there 4F0 in here? There is not. That is a bit unfortunate. It might be that 4F0 is actually not in hex. We don't know. Well, it is ID 1264. So Let me just search for that. I can't find that. Okay, that's a bit unfortunate. Let me just see. Ah, right. Okay. It is actually. Oh yeah, I'm a bit silly. These object alloc setups are looking for object IDs and not for DLL IDs because we're loading an object. And we can just see that 1264 is flame blast, so we can just paste this here, and this just works perfectly fine. And then similarly, D4, I think we previously found out this is 212, so this is probably object Kyte. It is not. Let me just search for 212. It is fx emit, whatever, and this still works. Awesome. And then again, we can double check here, and it's pretty much the same. And what we can do now is, given that we can see here in the tricky that there are already setups for these, we can just use these setups instead of creating our own. So let me just do this, and then do the fx emit setup as well. Do this, and we can remove all of these values because they are not needed anymore. And now you can see it's complaining about it doesn't know what these are about, and that's fine. We just need to actually have these defined in our DLL. So what we can do is we can search where these setups are coming from, and it's coming from this header. And we can actually include this header in our DLL. So because I'm lazy, I will just copy these three because I know I need the fx emit and we need the flame blast. I will go to the very top. I will include these here. I can remove the sidekick toy, although we probably need this in the future. We don't need this right now, so we don't need to include this. I can regenerate the context because I changed the header files that are included. I can copy the context. I will copy the context here as well. And then hopefully things are working out. Well, they aren't. And that's because it doesn't know these fields. Now let's see. Let's go back to Tricky. To the function that we just looked at. And we can see, oh, okay. We could have actually inferred this I times 10 here as well. So this I times 10 is the timer, and then you can see things are cleaning up a bit. So let me actually just go ahead, oops, and do this, select all of these fields, and then hopefully I can similarly select all of these and then paste these here, and then hopefully things are looking a bit better. They are, which is awesome. And then we just have to replace these setup names like this, and we are matching again. Awesome. All right. Now it's complaining about it's complaining about these object create calls, and that's because they are expecting a OBJ setup. And we can give them the OBJ setup by doing this, and now we don't see any warnings anymore, so this is now ready to be put back into the code, which is awesome. Alright, let's just do just that. So go back into the code, and then go back into here, and then move the struct to the very top, as per usual. And then again, we want to investigate why there might be differences here, but let's not do that right now. Let's just first see whether or not this still builds or not. Which it does, which is awesome. So we did something correctly here. Now, there is nothing to clean up here for the minute. So since this is going to be quite a large function, as we can see from the size here, I will actually go ahead, and before I continue here, I will go ahead and see what this is about. And then let's see. So where did we actually use this before? we use this here, and this doesn't matter. This just is like we know the size here. All right, so we are doing something here. So we thought that this might be correct. Okay, and then similarly here, and then similarly here. Okay, so we know that this is definitely the OBJ data, or the object data, but for these two we don't actually know. So these could be different structs altogether, which looks quite likely right now. So let me actually do that. So my guess is that this is actually DLL 212 data, and this is something else that I don't know right now, but I guess we'll figure it out. So let me just go ahead and take this function name and create a new struct. So just do type-def struct this, and then I will actually copy all of this, because we know that this is whatever is necessary here. And then this I will replace the data call here, and actually I will name this DLL 212 this, because that's a bit clearer, and then that's looking a bit better. And now we should be able to hopefully replace this, and then pad 9 becomes pad 34, and we will replace this, and then hopefully when we run the build command again we should be good again. We are. Now we need to just replace this as well, and then build again, and then this should still work. It does. Awesome. Now a little bit of cleanup that I forgot is naming arg0 self, and then arg1, because it's the object's data, we just call this obj data. I think it's written this way. Let me just double check. Oh yeah, it is. Awesome. All right, then we have figured out, well, we have kind of figured out what might be wrong here, but we also kind of haven't. We can tell that this function seems to actually take in the data, because it is unloading a DLL that's in arg0, it's destroying an object that's in 10 and arg4. So this is basically the same or very similar struct that we just build up ourselves. So you can see it also uses pretty much the same fields. So we can just go ahead and assume that this is the same. Which means that we can just do this and take or copy over these fields to here and save, and then build again just to check that the size is still correct, which it is. Awesome. Now we can get rid of this struct and this struct, and they're just using the data. This struct already isn't used anymore. This struct, however, is still used. So let's just do this. And then rename arg1 to be the next function can be done the same, obj data, and then this one can also be replaced. Now let's go back to the top. Is this struct used anywhere? It is not, which is awesome. And now we just have one anonymous struct that we can't fully tell what it is just yet, and we just have the data. And I think that's a good wrapping up point. And then in the next episode we will be tackling this function and possibly this function, depending on how quick we go through this. But that's going to be it for now. If you enjoyed what you were seeing, make sure to do all the YouTube stuff that you know or probably already know. And if you have a specific wish, desire, suggestion, feel free to also post it in the comments. That being said, hope you're having a great day, and see you next time.